Okay, so in some cases you may be given the formula. So like, for example, here, they've said consider y equals x to the power 4 over 5. They've asked you to identify the variables. Remember, they're the things that change. So in this question here, which would be my variables? Okay, which things are the things that change? Remember, they normally are referred to as letters. Sarah? Well, the variables themselves are just the... No, now you're just shouting stuff out to me. No, darling. Sienna? Well, it's the variables themselves are just the x and the y. Okay? Yes? All right, do we understand that? So the variables... Okay, so let me try this. The variables are y, thank you, and x. Okay, so the variables are y and x. Now, the things that are in proportion, that are directly proportional, are what Sienna said. So y is proportional to x to the power 4. Okay? But also in here, we should be able to identify our constant of proportionality. Now, I've actually chosen this example in particular because I think this is one of the more difficult ones. Because I'm trying to say, well, hang on a minute. Remember, our rules, our method of doing this is we would normally change this to be y equals k x to the 4, yes? And then we work out what this number here is. So what we have to do is say, well, we've already got the equals here. What number is in front of the x to the power 4? Now, this is a sneaky one. If I had said that it was y equals 5x to the power 4, that hopefully is quite easy. What's my constant of proportionality for this one? What number is instead of the k? 5. Yes, so for this particular example, k would be 5. Now, is anyone sitting there saying, what on earth is she on about? Okay, so Sarah and the other two that put their hand up. So here this says, okay, yeah.
So, because you took k, and I understand you got the 5 from when it says consider in the blue box, where that it...
Well, actually, do you know what? 5 was a rubbish example. Let me change my example here. I stupidly chose 5. If I had written 8x to the power 4, okay, in this particular example, my value of k would be 8. So this is a different example.
Oh, okay.
Okay? So that's different. It's a different question to the one up here.
Yeah. Right.
So
on the last part that we just did on the real question, why don't you put k over 4? I mean k to the x. Isn't that how you... Never mind.
I'm not sure what you mean. Okay, so here I went through my normal process. Y and x are my variables. We then say y is proportional to x to the power 4. And then we would say y equals kx to the power 4. So we then would find out the value of k. Now, they've done all that work for us. We don't know any information. They've done all the hard work because they've given us this formula. Now, if we'd been given this as our example, I'm hoping that you would recognize that k is the number that's in front of the x to the power 4. Do you see that? Those people that said they didn't know where it came from? Sarah? Vintage? Emily? So do you see the k is sitting here in front of the x to the power 4? So in this example here, what is sitting in front of the x to the power 4? An 8. That's why k is 8 here.
Do we know what number k is right now?
In our question,
yeah,
we're going to work it out. Okay? So I'm saying if it's a big fat number, normally it's pretty straightforward. So if I had y is equal to 3.7 x to the power 4, what would my value of k be? 3.7. Yeah, we get the gist of it? Okay, these are two both different examples. Oh, shiver me timbers.
Where did that come from?
No idea. Okay,
I think it says instead of erasing it and getting rid of all that, in the top
just undo.
corner, yeah.
Good idea, thanks. Okay, so K was 3.7 in this one. Now, so we have to say to ourselves, okay, in our question, what's the value of K? Now, I've got something over 5. We have talked about this before. When something is being divided by 5, it's saying it's the same as doing what to that number? How could I split this? How could I split it so it is something in front of x to the power 4? Vintage? You're not going to multiply it, no.
Like make it into an improper.
Pardon?
Make it into a fraction.
It is already a fraction, correct. What fraction would it be that's in front of x to the power? Pardon? Not an improper one. Not a mixed number. Now you're just saying fancy maths terms to impress me, I'm sure. So what fraction is in front of x to the power 4 here? Tell me more. You don't have to work anything out, sweetheart. No, you just have to recognize what fraction is it in front of the x to the power 4. Do you want to guess, Maya? It has to be a fraction. Now, if I told you it was
This is a guess. Is it 4/5?
not 4/5, but you're close. It's good girl, Hannah. It's 1/5. Awesome work. I think that's good teamwork. Pardon? Here's my x to the power 4, sweetheart. Yes, so that hasn't changed. If I had x to the power 4 over 5, it would be the same as having 1/5 x to the power 4. It's still there, darling. Just there, look. Because the 1 is we're not substituting something, we're just separating it. Okay? So what I've done is I've taken y equals x to the power 4 over 5, and I've said, right, well, there's a secret 1 in front of here, yes? And then the number that's in front of the x to the power 4 I can see is then 1/5 x to the power 4. Do you see that? So I had a secret 1 here, so that's 1/5. Now, if I had y equals x to the power 3 over 7, my variable that's proportional would be the x cubed. Can we all see that? What's the fraction that would be in front of that one? Indigo? 1 over 7. Awesome. Because again, there's a secret 1 here. I can't hear you, darling. It can go next to the 1, or it can just go after the fraction.
Is that another one of your examples?
Yes, these are different. This is a different example. Pardon?
Where did the 7 come from?
Okay, I'm trying to do as many examples as possible to try and help you. Okay? Now, if I had y equals 2x to the power 5 over 9. Okay? Another example. Now, let's think about which are my variables. So what am I going to separate? What's my x part? Maya B? Yeah, tell me what. Oh, beautiful. Are we understanding what's happening? Is there anyone sitting here still thinking, what on earth is this woman on about? Because now's the time to tell me. So, when you've just got an x to the power 4 over 5, okay, we think, right, there's a secret 1, so that makes it 1/5. x squared cubed over 7. There was a secret 1, so it was 1/7. If there's a number there, then obviously that stays as your fraction, okay? So for these particular questions, we could identify our value of k. So this was our original question, wasn't it? Okay, so this is where k has a value of 1/5, because we know that we would have split it like this, and that the constant of proportionality was 1/5. Vintage.
So basically what you do, like where you have not the example, yes, not up there. So when it's y equals 1x to the power of 4, do you just like move the x?
Yes, so you're going to move the x away so it's on its own, and then have the fraction in front of it. Okay, and that's what we were doing here. Like when we had 8x to the 4, we just moved the x to the 4 separate, and we could see that 8 was in front of it. Yes, it's just a little bit more challenging when there's a divide, because you have to recognize that it's 1/5. Yes, that would be the constant of proportionality. Okay, I've probably sent you all over the edge not knowing what's going on there. Right, so sometimes those questions come up. Now, I want to also go on to inverse proportion, because I need to make sure that you're taught all this so that you can practice it ready for the test, because this stuff's going to be in there. For that part, yeah.
When you understand it and don't get confused, I don't know.
All right, okay, so we've looked at directly proportional, yes? We're now going to look at inversely proportional. Now, the process and method is really, really, really similar, okay? Here's the trick. If things are inversely proportional, when one of the variables increases, the other decreases, okay? So when one is multiplied by something, then the other number is divided by the same value, okay? So if my numbers here go up by 2, so if they're doubled, then our numbers here would be halved. Does that make sense? So here, from 1 to 2, what did you do to the number 1 to get to 2? You doubled it, yes? You multiplied it by 2. So that meant you would have to divide this number by 2. Do you see that? So here from 1 to 2, we've multiplied by 2. And so that means from 6 to 3, we divide by 2. How'd you get from 1 to 3? You multiply by 3. So from this, you would divide by 3. Does that make sense? So from 1 to 4, we would multiply by 4. 6 divided by 4 gives us 1.5, apparently. And from 1 to 6, you would multiply by 6. And from 6 divided by 6 gives you 1. What are you confused about, Abby?
The first part I understood. When you did the 1 to 4 and then the other part on the y, I was confused.
I'm not sure.
So you did 1 to 4 on the top.
Yes, I multiplied by 4.
And then what does match on the bottom?
Divide by 4.
Or what does it go from?
From the 6, darling,
To
to
the
the 1.5. Okay? So if you multiply something, you divide the other. Okay? Now, notice there's only multiplying or dividing going on. There's no adding or subtracting. Okay? So you can't say you've added something, so you're going to subtract it. You're either multiplying it or you're dividing it. Now look at the kind of graph that we have here. As I said, as this one increases, this one decreases. So these are inversely proportional. Okay, you look at this graph, you can't see that this decreases, darling? Or can you see it decreases? Goes down.
But it could go up.
No, we read books from left to right.
Oh, alright.
Okay, it's a similar principle to the gradient situation. Now, okay, so the velocity v of a body traveling a fixed distance is inversely proportional to the time taken. Now, the best way of doing inversely proportional is to set it up a very similar way than that we have done up until now. So, v, velocity, I'm going to use v for velocity, is inversely proportional. So they've used the word proportional, so I'm going to use my constant of proportionality. Pardon? Okay, but it's inversely proportional, so what we do is we say 1 over the time taken. Okay, so when if something was directly proportional, we would just say v is proportional to t. But because this is inversely proportional, we write 1 over t. Is that okay? Yes? Amber, you put your hand on your head. Is that just, you're good with that?
Oh, yeah.
You're just resting, okay? So when it's inversely, we write 1 over. Okay? Then we carry on as we would have done normally. So we need to get rid of this sign, don't we? We can't use it as we did. So we would write v equals k over t. Okay? So the k replaces the 1 on the top.
Oh.
Yes, Abby. Okay. Do you remember all those directly proportional questions we've been doing the last few lessons? Pardon? It became equal k. This one has 2, look, darling. Look, equals k. Yeah. Okay, it just so happens that our other variables underneath this time. Well, there's a secret one here. If you want to keep it there, you can totally keep it there. Okay? You all happy with that? So then they've given us some more information. They've said when the velocity is 40, the time taken is 280. So what do we do now? Awesome, Imani. We substitute. So instead of the v, what number am I going to write, Vintage?
No, not 40 centimeters.
Good.
But quick question. So
Yeah.
instead of taking the 1 completely out, we just rest it there.
You can leave it there if you wish. I prefer not to leave it there, but Sarah was asking me where it went. So I said that it could sit there if you wish. Okay? And then divided by, well, we need to give the other information. So the other information, that the time taken was 280, yes? So the 280 is going to go there. So these steps here are exactly the same steps as we did for directly proportional. We wrote our proportional statement, we would change it to be equals k, we substituted in the numbers, and we're going to find the value of k. Well, if something is equal to k divided by 280, how do I find k? Hannah Stockley?
Times it by 280.
Good, we're going to multiply both sides by 280, so k is equal to 40 multiplied by 280.
Wait, I'm confused. That's a long number.
What are you confused about, Abby?
How did you go from the second last step to the last step one?
Because if I know if something here is divided by 280, to get rid of it, I have to times both sides by 280. Okay? That means that this is disappeared.
How come you didn't write anything like... Wait, so on the last step, you just wrote 40 times 280, but you didn't write
Do you want me to leave it on the same side as I had before? Bless you. Is that better? Okay. Now, do we know what 280 times 40 is? I've got no idea. Hannah?
11,200. Wowzers. So it's not like 1 million?
No, darling. 11,200 is not a million. We would have said million. All right, so our value of k is 11200. Well, what happens to that then? What do we do with that? What did we do with it in all the other questions? Sarah?
11,200 over whatever 280 times 280 is, and then divide that.
No, once we've found the value of k, what happens to it? Where do we put it?
So you put it where it's meant to go.
Good, which is back here, yes? So our rule is now v equals 11200 over t. Now, what did I do to suggest, well, what did I suggest doing once we've got the value of k?
Finding out the value of t.
Well, no. Well, you maybe asked more information. I suggested perhaps put a box around it, okay? Because this is now the rule that we're going to use for any additional questions that they may ask us. Now, in our question here, right, okay, so this is my rule, yes? So v equals 11200 over t. This is the rule we have to use now. Now, they've only asked us to work out one thing. They've asked us to find the time taken when the velocity is 50. So, that means that the velocity is now 50. So what we're going to do is in place of the v, we're going to write the number 50 from our question. The rest of it is the same formula. So the 11200 doesn't change, and nor does the t. But this is what we need to find. Now, this is where sometimes mistakes happen for inverse proportion. Because what we need to do is we need to find the value of t. So t is on the bottom. So to find the value of t, actually I'm going to tell you what happens. I'm sure lots of you are thinking, I know. But what actually happens is that this and this switch. Okay? So what happens is that we write t equals 11200 over 50.
Oh, wow.
Okay? So those two switch.
And then you divide?
And then you literally just put that in your calculator and tell me what the t is.
224.
Thank you.
And that's not it?
And that's the answer.
Ah.
Way easier than the
That's kind of cool.
Okay?
Well, because this is the easiest step. It's just like B and C. Yeah.
Okay, exactly, Vintage.
Yes.
Exactly. The hard stuff was this all up here, wasn't it? Okay? And that's the same in all of the questions, bless you. So in every question that we've done, the hardest bit is always getting this initial formula. Once we've got the formula, then those other bits are normally quite straightforward. We're just substituting in values and having a bash at them, rearranging stuff.
Interesting.
Yes, Abby?
For the last part, did we have to find what we...
Yes. Okay? Right. All right, so this example here, it says P is inversely proportional to S. So our first statement is P is proportional to, we don't just write S now, do we? Because it says inversely. Nice, 1 over S. That's our first step. Okay, because it's inversely proportional. Try and make it look like an S and not a 5. Mine's not great. Then what's our next step, Amy? What do we do now? Yep. You're the only Amy in here.
P equals K over S.
Beautiful. Beautiful work, people. I love it. I love it. So P equals K over S. And then we look to our question. We need to see if they've given us some information to find to find K. They told us that P is 12. So I'm going to put 12 in place of the P. And they've told us that S is 15. So I'm going to say equals K, because they don't know that, over 15. Okay, just the same as we did those other questions. Look at the information they've given us, substitute those values in. Yes? Now, for an inversely proportional question, you're going to be doing some multiplying, because to find K on its own, we need to multiply both sides by what? 15. Good. Abby, you see why?
Yeah.
Because the 15s now cancel on this side, so K is 12 multiplied by 15. Do we know what that is? Hannah's our calculator queen.
180.
Thank you. 180. Okay. So K is 180. Yes, Imani. Oh,
So I wanted to.
tell me. Okay.
Wait, I have a question.
Okay, Abby.
Is it alright if I write it before I go to the step that you're on now, the new step?
Yeah.
Is it alright if I write the actual
Darling, you write whatever you want to in your notes, because they're your notes so you remember it, okay? So Imani, you're going to tell me my rule. P equals 180 over S. Now I'm hoping there is no one in this room that is wondering where we got any of those numbers or letters from. Is that good? Everyone's good? So the K was because we found the value of K here. And so that went in place of this one here. And the P and the S were always going to be there. So I put it in a box because that's the rule we need to find. Now, notice I didn't even read my questions. I didn't even have a look to see what they've asked us to do, because I know that for every question I do in proportionality, I need to do this. So then I'm going to have a look and say, it says A, obtain an equation for P in terms of S. Well, look, part A, I've done it. I'm just going to rewrite this to make sure that they know I know what I'm doing. So that's an equation, because it has an equal sign, in terms of, for P in terms of S. That's my equation. Emily.
S on 5 and S.
Yes, girls, I don't know how else to say this. You've seen the question. I've asked you several times to make sure that yours is an S. I've even commented that mine doesn't look great. So, yes, I can't do anything else. Now, it then says B, use your equation to find the values of P when S is 9. So now, part B, part 1. Indigo, what shall I do now?
So you do,
They want us to find P when S is 9.
so you do P equals 180 over 9.
Lovely, lovely. And we got that 9 from the question, yes? And what we need to do is just stick that into the calculator. Imani? 20, lovely jubbly. So P is 20. That's that question done. Again, they're the ones that you're always disappointed but that it's so easy. Georgie, well, how do I do the next one? Okay, well, we got the 60 from the original question. Equals 180 over S. And now remember what happens, how do we find the S? Good, because the S and the 60 switch. And S is 3. Awesome work, people. I'm loving it. All right, so this last example here, we've got y is inversely proportional to the cube of x. Remember, the cube of x is just a fancy way of saying x cubed, or a different way of saying x cubed. So we say y is proportional to 1 over x cubed. Why have I written 1 over? Because it's inversely. Good. We replace that then with y equals k over x cubed. Yes? Because that's what we've been doing every other question. Then what do I do? I need to find k. So how do I do that, Vintage?
So you would do 1 equals k over 4.
Good girl. And then rearranging this to find k on its own, I would say 1 times 4 cubed equals k. And 1 times anything, always follow BEDMAS, so you do the 4 cubed first and then multiply it by 1. Obviously, anything multiplied by 1 is itself. So this is going to be 64 is equal to k. Where does that 64 now go? Amelie.
It goes to, sorry, is that 4 cubed or is that 43?
4 cubed.
It's, we go
So what do I write?
64, no, sorry. The,
Y
yeah, y
equals
1 over 64.
no.
Oh, 64 over x cubed.
Good girl. That's right.
Oh, really?
And then that goes in my box. Okay, because that's my formula I'm going to use. Now, did it ask me to find a formula? No, but I know I have to do that. Okay, so I've done it no matter whether I've been asked to or not, because I know I'm going to need it. Because now the question has said, find x when y is 8. So I'm now going to substitute the value of 8 in place of the y. So it's going to be 8 equals 64 over x cubed. And again, our rule is that we switch these two things. So it becomes x cubed equals 64 over 8. Now, what is 64 over 8? 8, okay? Now, that means x cubed is 8. This is a review of undoing cubing. What's the opposite of cubing? M squared? Cube rooting. Good girl. So we're going to do the opposite. So we find the cube root of 8, which is 2. Thank you, Georgie. Now, I'm really sorry that was a little bit rushed there, girls. I'm going to save that so you can have a watch of it again later if you need to, and we'll